I guess we should start by looking at what we use to create websites so far. So for pretty much all of us, what we've used up to this point is HTML and CSS. So we use HTML to define the structure of a document, the structure and the content, okay, by using HTML tags to say this is a heading, this is a paragraph, this is a division, and so forth. And then CSS to define the styles. So how the content should look and how it should be laid out on the page. So these get us a long way. We can create pretty full-featured web pages with these technologies. But the thing about both of these languages is that they're static languages, which means that essentially they're used to render the page, and then once it's rendered, we don't have any way of necessarily interacting with it. So for that, we need some sort of dynamic programming language, and the programming language of the web is JavaScript. So that's essentially the behavior that JavaScript allows us on top of HTML and CSS. It allows us to start adding interactive behavior to the page. Now, JavaScript is a client-side language, and we make that distinction as opposed to a server-side language. So when we think about the client-server model, the web server being the computer somewhere in the internet there which has the website on it, the client being your computer and your browser that you access the site from. So with a client-side programming language, really this just determines whereabouts the programming language is executed. With a client-side programming language like JavaScript, the code itself is actually sent to your browser, and it's the browser that executes the code. Okay, as opposed to a server-side language, something like PHP or ASP, that actually gets executed on the web server itself, and it's only the resulting output of that programming language or that script that gets sent to the browser. Now, I do have an aside here that JavaScript actually can be used as a server-side programming language, and actually even a general-purpose programming language. And this has become popular more recently with things like Node.js. But for our purposes in this unit, we'll strictly be looking at JavaScript as a client-side language. But it does mean if JavaScript is your first sort of introduction to a sort of fully fledged programming language, it's a good one to start with because it's actually the most popular, most commonly used programming language on the planet at the moment. And it's expanding into more and more different areas, even away from the web. So I guess the first thing we need to know is how we include JavaScript in a page. And we have two ways of doing that. Essentially, it's similar to how we include CSS styles in our web page. So as with CSS, we can include them either in a style tag within the HTML file itself, or we can link to a external file as well. So just like we'd link to an external CSS file, we can also link to an external JavaScript file. So this is an example of the first method here. Here's a very simple HTML document. Okay, and essentially we use the script and the closing script tag so that the thing that parses our document knows that the stuff that we write in between those two tags should be interpreted as JavaScript and not as something else, not as HTML, not as CSS. Okay, and then this is the example of including it from an external file. So essentially we still use the script tag, but rather than writing the JavaScript within those script tags, we use the source attribute, much like we'd use the source attribute on an image to point to an external image or a CSS file. We use the source attribute to point to an external JavaScript file. So in this case, it would be looking for a JavaScript file in a JS folder and then a file called main.js. So they're the two ways. And as you work with JavaScript more, you'll tend to see that generally the recommendation is that you try and keep your JavaScript in a separate file. So while these are both perfectly valid ways of doing it, the benefits of having our JavaScript in an external file are pretty much the same benefits that we get with having our CSS in an external file. Okay, so first of all, we're keeping our different languages separate, so it's easier to maintain. But also, if we have a JavaScript in an external file, we can then include it in multiple different other HTML files. If we had included everything in line and we wanted the same script, we'd have to repeat the same inline script. So generally, examples that you'll see me do, and most that you'll find on the web will, once they reach past a certain complexity, we'll probably always use an external JavaScript file. Now, one important thing to note is the order of where you place your scripts actually matters. Okay, so in all of these languages, okay, it starts at the top and it goes through line by line and processes the code that way. But the important thing to know is that wherever you put the script tag within your HTML document is where that script is going to execute. So it's common for you to actually include multiple external JavaScript files, and some files may rely on other files. So for example, it's common to include a JavaScript library like jQuery. Okay, and if your own JavaScript relies on features of jQuery, you need to make sure that the jQuery file that is required actually gets included first. If we switch these around the other way and I'm trying to access features of jQuery in my main JavaScript file, it won't know what I'm talking about. Okay, so the order of how you include them matters, and that goes for whether you've got inline scripts or you're linking to external scripts. Now, in terms of where in the HTML document you should be putting your script tags, it's actually valid to put your script tags anywhere either in the head section of the document or the body section of the document. And you can space them out across, sort of throughout the document where you want. Although having said that, best practice is generally considered to include them as the very last thing before your closing body tag. And the reason for this is to avoid something called render blocking. And what that means is that if your HTML file is being downloaded and you have your scripts high up, say in the head section before any of the body content, before the browser can actually display the HTML in the body, it needs to go through and load the JavaScripts that you've linked to at the top of the file. So while it might seem a trivial difference and the speed difference might not be that much, depending on how large your scripts are, it can result in a fairly large delay before you actually end up seeing content on the screen. So I've got a link here which explains in more detail about render blocking, but the takeaway from this is that really unless there's a good reason that you need to include your scripts higher up, the best place to put them is just before the closing body tag. Okay, so now we need to talk about something called the document object model, or the DOM. And what the document object model is the browser's internal representation of the page once it's passed all of your HTML document. And what it does is it builds up an internal tree structure, essentially, of all of the HTML elements on the page. And so when we're talking about the DOM, we talk about it in the language that we talk about a tree. So, and a good way of visualizing it is actually if you look at the browser's dev tools, which I'll open them up just here for this particular page. And if you look in the element section of your development tools, okay, you'll notice that here is a visualization of the tree. So at the root, if we look at the tree as sort of the peak at the top, and think of it like a family tree with the highest ancestor at the top, and then all of its children and grandchildren coming out like this, then the top or the root node of the tree is your HTML element. And then underneath that, you can see there's a head element, which itself contains all of the stuff that's in the head section of the document, and a body element, which contains all of the stuff in that. And then if I have, for example, a div, which contains other things, you can see it's all everything's represented as a hierarchical tree of nodes. So this is what the DOM, or the document object model, is. It's a representation of this. Some people, well, a lot of people, a lot of introductions to JavaScript tend to neglect talking about the DOM, and people end up thinking that what they're interacting with is actually the original HTML source. So again, this may seem like a trivial distinction, but it becomes important as you get further into the area of working with JavaScript, is that when we're using JavaScript to interact with the page, what we're not actually accessing the original HTML source code. Okay, the HTML gets passed, it generates in the browser's memory this document object model, and it's that which we can then change and do whatever we want to with JavaScript. Okay, and I'll talk more to that a little bit later as well. I do have a link here which again goes into more detail about what exactly is and isn't the DOM, which is worth a look, but I won't go through it now just to save time. So given that JavaScript interacts with the DOM, essentially that it almost always involves two steps. What we want to usually do is select a particular element or a particular node of the DOM tree and then do something with it. So we call that selection and mutation. So we select a part of the page that we want to do something with, and then we change it in some way. So this is an example here, and this is the first of the examples I have embedded from this site called JS Fiddle. Which is really useful. It's similar to, in some of the other tutorials I've been using a different one, CodePen. It's essentially a hosted environment to allow you to play with JavaScript, essentially. So any of these examples from JS Fiddle here, you can click on these and actually play around with the code and see the result. So you can see it's essentially broken into 4 windows here. There's the HTML, the JavaScript, the CSS, which there's none for this example, and then the resulting output of this. Okay, so this example is to demonstrate that process of selecting an element and then doing something with it. So if we look at the HTML up here, okay, I've got a heading, a paragraph, and then I've got this third empty paragraph here. Okay, so in my HTML source code, there's nothing inside of that paragraph. So, but as we can see in the resulting output, there is actually something here. So this hello text here is actually being injected by JavaScript. Okay, and the way that it does that is with a statement that looks like this. Okay, so document.getElement by ID output. That's sort of the selection half, and I'll explain this syntax more later, but what that's doing is saying go through the DOM and find me the element that has this ID of output, and then set this inner HTML property to equal hello. Okay, and so the inner HTML property refers to basically what exists between the opening and closing tags of that. So all in all, that one line of JavaScript selects that paragraph element there with the ID of output, and then sets the contents of that to be the text hello. Okay, so very simple example, but it demonstrates that selection of an element and then mutation of it, doing something with it or to it. Okay, so let's take a step back a little bit and just talk about the JavaScript language. So learning a programming language is actually quite similar to learning a foreign language. And in some ways it's actually simpler. A lot of people don't believe me when I say that, but trust me, it is. So, I mean, we have things like there's a vocabulary of words that you need to know that do certain things. There's a way of organizing these words so that it does something meaningful, so something like grammar, and then there's punctuation to allow us to, for example, say this is the end of a sentence, which in programming we call a statement, and other things like that. Okay, so it's got all of the similar similar properties of any non-programming type language. It's simpler because, in the way that it's simpler is because, well, for a start, there's something like 400,000 words in the English language. There's probably only a few hundred in the JavaScript language. And you can do a lot with much, much less than that. Also, if you know anything about languages and how they work and how they sort of one blends into another one and they combine stuff, then you know that rules from one language and another blend, and the rules for grammar in the English language are actually quite convoluted. In any programming language, they're actually much less ambiguous. And you know, if there's one way of doing something, there's one way of doing something, and it sort of makes sense. Where it is more difficult is in how we need to be much more precise when we're writing a programming language. So you probably know if you've ever interacted with someone, spoken to someone who's been trying to learn English, they can speak pretty broken English and you can still understand a lot of what they're saying. And that's because people are good at doing that. People are good at sort of inferring meaning from a broken set of words. But computers aren't good at that. Computers will do exactly what you tell them, and they won't read between the lines of what they think you mean. So what that means is that if you forget a single character or you have a single mistype, it can make an entire script, entire program not run. So that's actually the more difficult part. The part of understanding the language and what it does is actually should be easier. But we just have to be very careful that we're very precise with how we write it. And you will make a lot of mistakes at the beginning, but that's how you learn. You'll keep forgetting to put things in, and you'll see that it generates errors, and then you'll remember. And hopefully you'll get to a point where you can write code reasonably effectively without having to go through and figure out where all the bugs are. Okay, so let's look at, oops, let me bring that back. Oh no, I disappeared it. Okay, so we will look at, I'll reload this. Okay, let's look at some of the things that go into the JavaScript programming language. And I suppose the good thing about this is if you have any experience with any other programming language, a lot of this should seem familiar. But equally, if you don't have any experience with any programming language, once you learn this about one, you kind of learn one programming language, and you know a lot about any. It's quite easy to pick up other programming languages after you know one, because just like non-programming languages, they do share sort of common ancestry, and there's a lot of similarities between most modern programming languages. Okay, so we'll start with defining what a statement is. A statement is essentially a single line of JavaScript code. Okay, it's an instruction to the JavaScript interpreter to do a particular thing. So this is a very simple example of a statement, alert hello, and what that statement tells JavaScript to do is to pop up a dialog box with that particular text in it, hello. Now an important thing is each JavaScript statement should end with a semicolon. So this is kind of like ending a sentence with a full stop. It's how JavaScript knows that this is the end of one statement and the thing that comes next will be a new statement. So it's a very common thing that people forget to do when they're starting out, is they'll forget to put a semicolon at the end of a statement, and so JavaScript, because it's not clever, it can't read between the lines, will think that the two statements side by side are one statement. Then we've got comments. So comments are a way of writing essentially exactly that, comments into our code, which we don't want to be interpreted by the JavaScript interpreter as actual JavaScript commands. So it can be useful both for our purposes to remind us what a bit of code does, or for other people's purposes, because quite often it's more than one person who will work on the same bit of code, to basically, in a human readable way, say what this particular thing does. Now there's two ways in JavaScript of writing comments, similar to a lot of other languages, and basically the only difference is whether you want the comment to be a single line comment or you want it to run across multiple lines. So in order to write a single line comment, essentially all we do is start the comment with a double / character. Okay, so you can see in this example there's the alert hello statement, and then the part in orange after that is ignored by JavaScript, and it's purely there as a way to document the code. So I can remind that if I'm new to the alert function, never used it before, and I'm going to forget, and I want to remind myself what it does when I come back to it next time, I can write a little comment there that tells me that it shows a browser alert dialog containing the text hello. Okay, and then below that is an example of a multiple line comment. If we want the comment to span over multiple lines, then we simply just wrap the comment in a / asterisk, and then the reverse of that at the end, asterisk /. Okay, so they're comments. Now, variables. So quite often when we're creating a program, we want to remember a bit of information and then reuse it again at some point later in the program. So for this, we use something called variables. And the way that we create a variable in JavaScript is we first have to declare it. So basically say to JavaScript, we're going to create a variable and we're going to call it this, and this is what I'm going to refer to it as at some point later on when I use it again. So the way we declare a variable in JavaScript is to use this keyword var, and then we give it a name. So we make up a name for this variable, and it can be pretty much anything you want. There are some rules to naming it, but it's a name that you make up. And then we can assign a value to it using the equal sign, and then the value that we want to assign it to. So in this case, I'm creating a variable called first name, which will hold the value, the text string Dave. Okay, and then ending that statement with a semicolon. So I've got the list of rules here for naming a variable. Essentially, it can be pretty much anything, but it has to be one word. It has to, it can only contain letters, numbers, underscores, and a $sign. So no other special characters like that. You can't name a variable with a hash in it, for example. And they have to begin with a letter, a $sign, or an underscore, so they can't begin with a number. And you can't use reserved words. So reserved words are ones that JavaScript uses to have some sort of meaning. So for example, this var word here is a reserved word. That's how JavaScript knows I'm about to declare a variable. So I couldn't therefore create a variable called var. It would confuse it. It wouldn't know what I was trying to do. But other than that, you pretty much have free reign on what you can create as a variable name. One thing to note is that in JavaScript, variable names are case sensitive. Okay, so there's a difference between if I had written this as first name with a lowercase n versus an uppercase n, it would be considered them two different variables. Other than that, you can call it pretty much whatever you want, but it's good practice to call it something that relates to what you're going to use it for. Okay, so now when we talk about variables, the next thing we really need to talk about is data types. So there's a few different types of data that we can work with in JavaScript, and the JavaScript interpreter sort of needs to know what those data types are, so it can know what's a valid thing to do with them. Okay, so it needs to know if something's text or a number, because if we all of a sudden try and do multiplication on two text strings, I mean, what are you going to do with that, right? So we need to define data types. So the first data type we'll talk about is called a string, and string is just a word in programming that essentially means text. Okay, it's a string of characters, but in programming it's always called a string. The way that we write strings in JavaScript is to put them, the way that we write strings is to put them inside of either single quotes or double quotes. Okay, so here's a few examples of declaring a string with different combinations of those. The reason that it lets us use either single quotes or double quotes is because it makes it easier to define a string that has, so in that line 3 example, Dave's class has an apostrophe in there. If I had have declared this string with single quotes, then it would get confused and think I'm trying to close the string with that first apostrophe. So by wrapping the whole thing in double quotes, using the apostrophe there, it makes it work. Okay, you might though come across an issue where you need both quotes, single quotes and double quotes within the string itself. So example here, if this is a quote of the day and I'm trying to have the quote in inverted commas, but that also includes an apostrophe as well, then the other thing you can do is what's called escaping a string character. So you'll notice that in the your there, where there's the apostrophe, I can put a backslash in there, and when that string gets output, it will know that that's an apostrophe is part of the string rather than actually attempting to close a string literal. Okay, but most of the time you can avoid having to do that by just choosing whether you use the double or single quotes. So that's text strings. That's pretty much all there is to text strings. Then we've got numbers. And these really are the bulk. It's amazing that you can pretty much do everything with some combination of either a string or a number in JavaScript. So numbers obviously represent numeric data. In some other programming languages, there's actually different data types to represent different kind of numbers, like integers or whole numbers versus decimal numbers. Okay, in JavaScript, it's simpler than that. Essentially, if anything's a number, it's the data type is a number. And numbers are declared by essentially just writing the number without quotes. So this first line here, where I'm declaring my number, is 123.05. Okay, if in this second example here I actually put quotes around that, even though it's a number, because I've defined it with quotes, JavaScript's going to treat that as a string. So I can't expect to go and be able to do, for example, multiplication, addition, subtraction with it. If I want to use it as a number, I need to declare it without the quotes. Okay. Okay, now the third data type I want to talk about is a Boolean. And a lot of people at the beginning go, what's the point of having a Boolean? We could do it with a string, but you'll see a little bit later where it becomes useful. But essentially a Boolean value holds one of two values. It's either true or false. So we use it for essentially testing a conditional statement. If we want to test whether something is true or something is false in order to decide what to do next, okay, the result of that is always a Boolean value. And we assign it with the words true and false, which, as you'll notice, are not in quotes. Okay, so they're just words written by themselves. Okay, and again, I've got a link to more detailed explanation of all these data types that you can look at there. Okay, so far we've looked at essentially single data item data types, numbers and strings and Booleans. Now to build on that a little bit further, sometimes we want to store a list of data. And when we want to do that, the thing that's useful for doing that is something called an array. So you could think of an array as a list. You could pretty much use that term interchangeably. So I've got an example here where let's just say we want to store a list of ingredients for a recipe. Now, if we didn't know about arrays or arrays weren't available to us, one way that we could do it would be to declare 5 different variables, ingredient 1 through to ingredient 5, and create each of these as a string. Okay, but a better way to do this is actually to use a single variable, a single array variable that can store all of those. So I can essentially store this same information in a array by using this syntax here. So essentially the way that we define an array is with this square bracket notation, and then we just declare the items that we want to go inside it. and they can contain whatever data types you want. So although these are all strings, I could mix them up. One could be a string, one could be a number. I could even store another array within inside an array if I wanted. Okay, but an array is a list of items, and that's how we declare it. But given that, we then sort of need to know, well, how do we reference any particular item within this array? And the way that we do that is represented by this example here. Essentially, again, we use this square bracket notation. And if we want to access a particular element, we write the name of the array variable, and then in square brackets, we write a number, which refers to the position in the array that that particular item is. Now, the one big catch here, the one thing to know, which trips a lot of people up when they're starting out, is that array indexing starts from 0 and not 1. Okay, so the first element in the array is going to be at position 0, not position 1. So there you can see at ingredient 0, you're going to find flour, ingredients 1, you're going to find sugar, and ingredients 4, you're going to find the fifth item, which is eggs. Okay, so array indexing always starts at 0. Okay, now we'll briefly talk about arithmetic operators. Essentially, it's maths, stuff that lets you do maths. Okay, so we've got if we've got number data types, we can perform all of our usual kind of mathematical calculations using operators that should be familiar to anyone who's ever used a calculator. Okay, so we can perform addition, subtraction, multiplication, division, and then which should be fairly self-explanatory to everyone, but the bottom three you may not have heard of before. So the percentage sign here is known as the modulus operator, and what it allows us to do is to perform a division, but rather than getting the answer of that division, actually getting the remainder that's left over. Okay, so that can be useful for a lot of things. And then we've got the increment and the decrement operator. And sorry, that should actually be a double negative sign there. I'll need to update that. But it's either plus plus or minus minus, and what that does is a shorthand way of either adding 1 to a number or subtracting 1 from a number. Okay, so they're all of your main arithmetic operators. Okay, so here's an example of the modulus operator in action. So if we have a variable x which equals 5 and a variable y which equals 2, and we create a variable z which equals x modulus y. Okay, so 5 divided by 2 is 2 and a bit, and the bit that's left over is 1. Okay, so that's allowing us to get that remainder 1 of the calculation of 5 divided by 2. Okay, and there's demonstration of increment and decrement. So variable a being 10, b is 0. If we go a plus plus, adds 1 to 10. If we go b minus minus, okay, we can have negative numbers, so 0 minus 1 will be negative 1. Okay, now interestingly enough, we actually have operators that work with strings as well. But really we actually only have one operator, and it's the plus sign operator, but when we use it with numbers, it's addition. When we use it with strings, it's called concatenation, which is essentially just a fancy way of saying join one string to another string. Okay, so for example, and sorry, I do need to edit this example again. There's a mistake in here, but so the first name and the last name variables, they should be in quotes, so they're strings. Okay, so let's just imagine they are, and then I create a third variable, full name, and I use the concatenation plus operator to join the first name plus a space character plus the last name. Okay, and the result of that will be a new string with my first name, a space, and then my last name. Okay, so that's the only operator really that you need to worry about with strings. But the catch with this one is you need to be careful sometimes when you're working with different data types how you use this. A lot of other programming languages will use actually a different character for string concatenation. But with JavaScript, you'll notice it uses the plus sign both for numerical addition and for string concatenation. So what you need to be careful of is when you're working with a combination of numbers and strings, that you're making sure it's doing the thing that you're expecting. So the important thing is, again, going back to remembering that if you truly want something to behave as a number, you need to make sure you declare it without the quotes. Okay, so in this example here, my variable a equals 5, that's a number. Variable b equals 10, in quotes, that's a string. If I was to attempt to do this third line, c equals a plus b, you might expect numerically it to come out to be 15, but what it will do is because it's treating b as a string, and it can't guarantee that there's not other letters in there, then what it's forced to do is convert the number to a string, and what you end up actually getting is a concatenation of the string 5 and the string 10, and so the output of that will actually be 510, not 15. Okay, so mainly avoiding that error is just making sure when you're adding numbers that you declare them as numbers, and when you want to concatenate strings, that you're working with strings. So in any situation where you're combining both, okay, what's going to happen is the numbers are going to be converted to a string. Because you can convert any number to a string, but you can't necessarily convert any string to a number. Okay, then we have comparison operators, which allow us to compare two different things. Okay, so, and this is a table which describes a bunch of these. We've got the equality operator. Okay, so we can't use the single equals for an equality operator because it's already reserved for assigning a value to a variable. So if you want to test two things for equality, you can use the double equal sign, which tests that the values are equal. There's another one which is the exact equality operator, which is 3 equal signs, which makes sure that two things are both the same value and also the same data type. Okay, and then we have not equal, which is represented by exclamation mark and an equal sign, and then a similar thing for the not exactly equal. Then we have greater than, less than, and then the last two are greater than or equal to and less than or equal to. Okay, so you'll see these a lot in examples when, again, we're trying to determine whether or not what the relationship is between two different variables or two different bits of data in order to decide what to do next. So comparison operators are usually used in conjunction with conditional statements. So far we haven't. So far anything that we've done has just been statements of code that get executed one after the other. But we've got certain constructs that allow us to execute one bit of code in a given situation and potentially another bit of code in another situation. Okay, we make a decision based on something. And so the simplest form of this is a conditional statement. And we write it looks something like this. Okay, so this is an if statement here. And basically what this says is if whatever we write in between those round brackets, okay, if whatever condition we write in those round brackets is true, then do whatever code we put inside those curly brackets. And that could be one line of code, or it could be 100 or 1,000 lines of code. Okay, so that's the form that a conditional statement takes. We can then expand upon that using else. So if we want to test more conditions after that, we can go, if this is true, do this. Else, if this other thing is true, do this. And then we can keep adding else statements to that as well. So I've got an example here in a JS Fiddle page to demonstrate that as a simple example. Okay, so again, the HTML is very simple. A heading 2 with a empty paragraph with the ID of output so that I can select it with JavaScript. And essentially this whole program is designed to see whether or not you're taller than me. Okay, so I've got two variables here. I've got Dave height, which is my height in centimeters, and then your height, which you can modify here. Okay, and then I've got this variable output, which I'm going to use to build up the correct output to insert inside of this paragraph. So, and it's going to output one of three things. Either Dave is taller than you are taller than Dave, or you are the same height as Dave. They're really the only three options here. So in order to figure out which one of those to output, I need to have some sort of conditional statement. So the first one I'll test is if Dave height is greater than your height. Okay, in this case it's true, so I'll execute this particular code and I'll set the output to Dave is taller than you. Okay, and because that one was true, it ignores these. Okay, it's not going to go into these other code blocks and bother testing those. And then finally here I'm selecting the output paragraph and I'm setting the inner HTML to whatever I've set as the value of this output variable. Okay, so with its default values there, okay, it's outputting Dave is taller than you, which makes sense. Now, if you happen to be a tall person, let's say you're 2 meters tall, I can run this, okay, and we see that the output has changed. You are taller than Dave. So it's come through, it's tested this statement here. Is Dave height greater than your height? No, it's not. So go on to the next one. Is your height greater than Dave's height? Yes, it is. So set the output to you are taller than Dave, and then jump out of this conditional statement, and then set the value of that paragraph to that particular output. Okay, and then the final case would be if we happen to be exactly the same height. I'll run this again. Okay, and in this case it comes through. First condition fails, second condition fails. So this else without an if is basically saying, well, if none of the other conditions were true, then do this last thing. Now I could have put a condition here that said if your height is equal to Dave's height, but I know that that's the only other possible option anyway, so I've just put it in an else statement. Okay, and that's how we get that particular output in output. Okay, so that's a conditional statement. Very simple example of it, but it allows us to execute a different block of code based on a particular condition being met. Okay, functions. Functions are very, very, very useful things, parts of any programming language. And essentially what they are is a way to define a block of code that can be called over and over again. So rather than having a bit of code just execute once and then the script end, a function sits there and it doesn't do anything until we call it, but we can call it as many times as we want. So this is very useful for reducing the amount of code that we need to write, because if we're trying to do a similar thing over and over again, rather than copying and pasting that code to keep doing it over and over again, we could declare a function that does it and just call that function whenever we happen to need it. So there's two parts to using a function. First of all, we define the function, okay, which is those first 3 lines, and we use the keyword function. You'll notice this is where syntax highlighting in your editor helps. You'll notice in these examples, anywhere where the word is purple, that's a reserved word in JavaScript. It means something to JavaScript. So in this case, it says that the next thing I'm going to do is declare a function. So function, then I give the function a name. The rules for naming of functions are the same as they are for naming variables. And then you'll notice there's an open and closed rounded bracket. Okay, and I'll explain what they are for in a minute. And then the curly brackets, which say this is the code that should be executed in between here when the function is called. So that's declaring the function, and then at some point later on, we call the function by writing the name of the function and then those 2 rounded brackets again. Okay, so the 2 rounded brackets, what they're for is for sometimes we might want to pass that function information to work with. Okay, and when we do that, we call those function parameters. So it's those rounded brackets or parentheses that are used for accepting those functions. So this example demonstrates that here. So again, okay, I've just got my empty output paragraph, and I've got a function here that says say hello. And inside of that function, it does again our document.getElementById output and sets the inner HTML to be the text string hello plus this variable name that is passed to the function. Okay, and so you can see down here when I call the say hello function, whatever I type in here ends up being sent to this function as that variable name and being used here as well, resulting in this output here. Okay, so if I don't want to say hello to myself, I want to say hello to Deb instead, I can change that there, hit run again, okay, and now Deb is being passed to the say hello function and being output like that. Okay, and I can call this function now as many times as I want. Okay, if I want to at some other point in my program call that again with a different value, I can do that as well. Okay, and the third thing that a function can do is actually optionally return a value. So it doesn't have to, but you can, if you want, return a value from a function to the line of code that was calling it. So this example here, okay, this example here, I'm defining a function which calculates BMI, or body mass index, which is just a simple calculation that's designed to let you know whether or not you've got a healthy weight range. Okay, so I've declared the function here, called it calculate BMI. And in order to calculate the BMI, the formula is your weight divided by the square of your height in meters. So in order to do that, I need an input height and an input weight. Okay, and then here what I'm actually doing is returning the result of that equation, weight divided by the height times the height. Now I could, if I want, split this up into another line, and I could actually declare a variable in here called BMI and set that equal to that and then return BMI. If that's easier for you to understand as two separate statements, then that's fine. But essentially all it's doing is it's ultimately returning the value of that calculation. So down here is actually where I call that. Again, I'm using document.getElementById to select this paragraph with the ID of output, and then I'm setting the inner HTML value to be the return value of calling that calculate BMI function with those values for height and weight. Okay, again, if it's a bit easier to understand, I could always split this up into multiple lines and do the BMI calculation first and store that in a variable and then output the value of that variable. Okay, so now I can call this and I can change these values. Run it again, okay, and I can see the number changing there. So if I wanted to do this process a number of times, let's say I had a list of, let's say I was a doctor and I had a list of patients and I wanted to calculate all of their BMIs. Rather than writing that calculation out several times, I can just keep calling that function with different input values. Okay, and again, these examples are fairly simple and trivial, and so writing that over and over again might not be that much extra work, but again, you could be trying to do this 1,000 times, and that function could have 1,000 lines of code in it. Okay. All right. So that's functions. That's pretty much everything there is to know about functions. Okay. So to summarize functions, they're repeatable blocks of code which can optionally take parameters and can optionally return a value. We declare the function and then we call it one or more times from elsewhere in the code. Okay, now we will talk about objects. Objects are another thing that are often skipped over in introductions to JavaScript courses, but they are integrally important to understand JavaScript. If you understand objects, it opens up a lot of deeper understanding to JavaScript for you. So objects are, like we talked about arrays, where an array was a list of items. An object is sort of like that, but rather than necessarily being an ordered list of things, it's a collection of variables and potentially as well functions that are related to each other in some way. Okay, so for example, again, the best way to demonstrate this is with an example. I can create an object So let's just say I've got a bunch of variables that describe me as a person, my first name, last name, my height, and my weight. Okay, I could declare these as separate variables, but because they're kind of all related to me, to keep them all together, I can declare this object called person, which I do again with a var keyword, and then the name person. That's again just the name that I've made up. And then I'm setting it equal to this object declaration here. And within this object declaration, these are all internal variables of that object. And when they're in an object, we call them properties. Okay, but other than that, they're the same as variables. I declare them slightly differently. I use the colon here instead of an equal sign. And you'll notice I'm separating them with commas here. Essentially, first name, last name, both strings, height and weight, their numbers. And then also inside of here, I can actually declare a function as a member of this object. And you might see them functions inside of objects referred to as methods, but they're exactly the same thing. So I could actually embed this calculate BMI function inside of this person object. And again, if we do that, that's fine. That's reasonably easy to understand. It's a collection of variables and functions. But again, we need to know how to access these. So we access properties and methods of an object by using what we call dot notation. Okay, so and this is an example of that here. So again, okay, my HTML here, I've got 2 paragraphs and I've got a span for my full name and a span for my BMI. Okay, this first part here handles the outputting of the name. And okay, we've seen this a bunch of times before already, selecting the particular element with the ID of full name. But the value that gets output, okay, is essentially this is what I'm talking about when I talk about the dot notation, is how I'm accessing that first name property of that person object. What I do is I write the name of the object person and then dot and then the name of the property that I want to access. Okay, so it's person dot first name, and then in this case I'm joining again my first name and my last name, so I'm performing string concatenation here with a space character, and then also the person dot last name. And in a similar way, I can call this calculate BMI function by again calling, referring to the name of the object, person, and then dot, and then calculate BMI function. So it's essentially the same as if they were not in an object, except that they are. So I just preface every property or function that I want to call with the name of the object and a dot. Okay, and you'll actually notice that this is notation that we've been using all along. If you actually look at if you actually look at, just pair it back to this simple line that we've been looking at here, we've been using all along, document.getElementById output.innerHTML equals hello. This is actually what we're doing there. Okay, so document is actually a built-in JavaScript object which refers to the whole DOM, the document object model. Okay, and getElementById is a function or a method of that document object, which we can call, and it takes a string which looks for a particular element with that particular ID. Now that part returns another object called an element, and that element has a property called innerHTML, which we access with .innerHTML, and we assign that to a value of hello. So this is kind of the 2 things in one line. Again, we can break it down into 2 lines if it makes more sense to you this way. So the first part, getting the HTML element with the ID of output. So this time I'm assigning the return of that document object getElementById function to a variable I'm creating called output element. And then that output element, I'm accessing the property innerHTML and assigning that to hello. Okay, so most of the stuff that you use with the built-in JavaScript stuff is going to be accessing objects and functions. Okay, and really all you need to know is that you essentially, if you want to refer to something within the object, write the name of the object and then a dot and then the property or the function that you want to access within that object. So we'll look at a couple of more built-in objects. Okay, so we have strings, which we've already looked at. Now, strings are actually objects which contain a bunch of properties and functions that are useful for working with strings. So, for example, every string that you create actually has a property called length, which tells you how many characters there are in that string. So if I create a string hello, I can access the length property of that string by saying myString.length, and the value of that will be 5. Okay, the string object also has methods. Okay, so again, if I take this myStringHello, there's a string method called substring which allows us to extract a part of that string from the bigger string out. And the substring method takes 2 parameters. The first one is the starting position, and then the second one is the number of characters that we want to extract from that. So again, like with arrays, the position actually starts at 0. So the position 1 will actually be the E, and the result of this function call will be to return those 3 characters in the middle of that string there. Okay. The math object. The math object is a built-in JavaScript object which contains a bunch of stuff which is useful for doing mathematical calculations. So things on top of what our arithmetic operators already add. So things that are more complicated than just multiplication, addition, subtraction, and division, and so on. So for example, this particular example here, okay, this example allows us to calculate the area of a circle based on its radius. And so I've defined a function here. So we've seen all of this sort of stuff before. The only thing that's new is what I've used this math object for. Okay, so if you remember how to calculate the area of a circle, the equation for that is the mathematical value pi times the square of the radius. So in this particular function here, which takes a value for radius, it uses the math object, which has a property called pi, which retains the value of pi to a certain number of decimal places. And then in order to do the square of the radius, I'm using this math function POW, which is short for power. Okay, and what this does is takes 2 parameters. The first one is a value, and then the second one is a number, which is the power that we want to raise this to. Okay, so this one is basically giving me the value of radius squared. If I wanted, I could make that 3. It would give me radius cubed, radius to the power of 4, and so on and so forth. Okay, and the last function that I'm using here with the math class or the math object is once I've set my radius here in a variable. I'm calling the calculate circle area with that value of radius, and then I'm outputting the value to this particular bit of HTML. Okay, so what I want to show you is what happens if I just output the area value as calculated here. Okay, you'll see it gives me a value to a bunch of decimal places. Okay, so again, the math class contains a function called round, which allows us to round any decimal number to the nearest whole number. And so I use that to output, instead of that heaps of decimal places, basically the area to the nearest whole number of centimeters squared. Okay, and you can look up the documentation of any of these. I've got links throughout the blog post. That link to basically what's available in terms of the built-in objects and functions. Another one is the date function. Okay, I won't dwell too much on these examples. Essentially, the date function allows you to do things with dates. Okay, so I can, for example, this example here, I won't necessarily go through the code, but it allows me to do something like output the day's current date. Okay, so that's something you couldn't do if you did this without JavaScript. You'd have to come back and update your site every day to say this is the current date. With JavaScript, we can just say it will poll the system clock to get the date, and it will output it like that there. So even though I wrote this code yesterday, okay, it's still working and it's outputting the current date. Anyway, date object lets you work with dates, and there's a bunch more built-in objects. They're just some of the more commonly used ones. Okay, quickly talk about loop constructs. So loop constructs allow us to essentially do the same, or do a bunch of lines of code a certain number of times. Okay, so and there's a few different loop constructs, but the one that you'll most commonly use is called a for loop, and it takes the form. It looks something like this. So essentially, for a bunch of stuff, do this. So there's actually three statements that go into this in between these rounded brackets here. Statement 1, Statement 2, and Statement 3. And Statement 2 is kind of the important one. Statement 2 is the condition that needs to be met for this loop to keep going. And then the other two are just a way for us to essentially create a counter variable that we can declare and then increment one each time. Okay, so the simple example that's always used to demonstrate this first is something like counting to 10. Okay, so this for loop here, this is essentially, so the first statement here is executed before the first iteration of the loop. So I'm creating a variable called I, and I'm assigning it a value of 1. The second statement here is the statement which gets tested every time through the loop to determine whether we should keep going or whether we should break out of the loop and then go on with the rest of the program. So I'm saying keep going through this loop while the value of I is less than or equal to 10. And then this third statement here is adding 1 to the value of I every time through the loop. Okay, so we can see that I is going to start at 1. Each time it goes through the loop, it's going to add 1 to that value, and it's going to keep doing that until that I is less than or equal to 10, no longer evaluates to be true. Okay, and essentially in the loop, all I'm doing is building up the output, outputting the current number with a line break tag. Okay, and then ultimately after the end of the loop, I'm outputting all of that, and we get the result there. Okay, so if I change this to 100, okay, it does it 100 times. Now, that's again kind of a trivial example, not that useful. Where loops constructs actually come in very handy is working with arrays. They lend themselves very well to working with arrays. Because an array being a list, and we might not necessarily know how many there are, if we go back to this example, of the various different ingredients, and we want to output all of these, okay, this is the way that we would do it without using an array. If we declare all the ingredients individually, and then we output them all like that. Okay, but a much more efficient way to do it is to store the ingredients in an array, and then in this example, we use a for loop here, and again, we're declaring a counter. At this time, I'm starting I equals 0, because remember, I want to reference I want to reference items in the array, and the array indexing starts at 0. So the first time through the loop, I want this ingredients I to reference ingredient 0. Okay, and I'm again at the end, after each loop, I'm incrementing I by 1, and this is the condition that needs to be met for the loop to keep going. So I'm basically saying keep going while I is less than ingredients.length. Okay, so the array is actually an object too. It also has a length property which tells you how many elements there are in the array at any given time. And notice here that I'm saying I is less than ingredients, not length, and not less than or equal to. Okay, and again, that's because the array indexing starts at 0, so the last element is going to be 1 less than the length of the array. Okay, and again, all I'm doing is building up the output string and then finally outputting it there. So the benefit of doing it this way over this way is a couple of reasons. First of all, without using an array, let's say I want to add another ingredient to this list, I have to create another variable, and then I have to add another line to this output code there. Okay, so when I'm adding data, I'm also having to add behavior, which is maintaining the code in 2 different places. Okay, but again, then let's say I want to add a particular class to each of these list items. If I want to do that here, I have to go through every single line and add the class there. And this could be, the list could be, there could be 100 items here. With this one here, if I add another element to this array, I don't need to change anything about my for loop because the length will always know the current length of that array. So I can take them away, I can add them, and this for loop will still always function correctly. And the other thing is there's only one line which builds the output. So if I want to add that class to every list item, I only have to add it in one place. Okay, so in programming, we generally try and look for the most efficient way of doing everything because it just makes our life easier when we have to maintain the code. So in examples that we looked at up to this point, we essentially, anytime we wanted to select an element from the document, we used this method on the document object getElementById. Okay, and then we also looked at using, once we select that element, its inner HTML property to assign it a value, and then that content gets injected into the document inside of that element that we apply it to. There are some other methods though in JavaScript for selecting and manipulating the DOM, and I won't dwell too much on it because one of the things that jQuery enables us to do is giving us much better methods of doing this stuff. But behind the scenes, with plain old JavaScript, you've got, well, we've already looked at document.getElementById, but you've also got document.getElementsByTagName. So that will return you a set of elements that match the tag name, which is any valid HTML tag name you put in as a parameter. And then you've also got document.getElementsByClassName, which matches a class name that you give it as a parameter. So I suppose the main thing to note is that with getElementById, it always returns a single element because the ID is meant to be unique on your page. These other two will return you a set or an array of elements. Okay, and then you've got other methods of modifying HTML elements. So there's setting the value of the inner HTML property that we've already looked at. You can also modify the attributes of any HTML element, and the way that that works is depending on what element you've selected, it will have a bunch of properties that map to the valid HTML attributes for that element. So for example, if the element that you select is an image element, then it will have as one of its properties a property called src, which allows you to set the source attribute of that image element. So you could, for example, select an image element in JavaScript and then make it load a different image to the one that it already has by overriding its source property here and pointing it to a different image. And you've also got this set attribute method of the element object, which essentially does the same thing as the element.attribute, but does it instead of setting the property directory directly, it takes two parameters, the attribute that you want to change and then the value that you want to change that attribute to. Okay, and I've just provided a link here, not that I expect anyone to necessarily memorize all of this stuff, but there's a link to Mozilla's documentation of all the HTML DOM objects that do exist that JavaScript can access. So you can see there's a whole bunch of them. Pretty much anything to do with anything that's rendered on the page, and as well as the browser and the document itself, you can access and interact with using JavaScript. Modifying CSS styles. In plain JavaScript, there's a couple of ways you can do this. You can, as in this example here, okay, what I've got here is an unordered list with 3 list items, and the second one I've given an ID of important so that I can select it with JavaScript. And then what I want to do is modify the style using JavaScript. So the way that I've done it here is once the element's selected, any element, any stylable element, HTML element will have a style property, which itself is an object with a bunch of properties that relate to CSS style properties. So for example, we can set the color to be red and the font weight to be bold. Okay, and then it applies like this. Now, in terms of what these CSS styles map to in terms of properties of the style object, they're all listed in a link here from W3 Schools. They're all listed, so each style and what its property name on the style object is. Although you shouldn't really need to look this up if you just kind of notice the pattern. So in this instance, if I had have written this as a CSS style, okay, the color looks like color, that's fine, that's the same. But anything that is a anything where in CSS, like font weight, in CSS would be written as font or lowercase hyphen weight. Okay, so anywhere where we have a hyphen in the CSS style, because a hyphen is not a valid character to use in a variable name or a property name in JavaScript, then they can't use the exact same thing. So what they've done is anywhere where there's a hyphen, essentially the rule is you get rid of the hyphen and use, instead of all lowercase, use camel casing, which is what you do when you use lowercase for the first word and then every subsequent word is uppercase. Okay, so once you know that, you can figure out what any rule would be. So you could have border radius, which would be written like this. Okay, and if I was going to do that, the equivalent property on the style object would be border radius with a capital R like that. Okay, so any CSS style you can apply by modifying the properties of the element style object. The other method of modifying the CSS on an element is to use the element's class name property to assign a class that you've already defined in CSS. So this is the same example again, except rather than manipulating the style object directly, what I've done is I've defined a class called redbold up here with the styles that I want to set. And then what I've done is, again, I've selected that important list item there, but rather than modifying the style property directly, I'm using element.className property and assigning it the name of the class that I've defined over here in my CSS. And this is generally considered a better way of doing it because, again, it keeps your style information in the CSS and out of the JavaScript. Okay, and the last thing we need to talk about is events. So pretty much all the examples I've shown you so far have only been doing stuff that really I don't need JavaScript to do. Okay, so there's no reason why I couldn't have just done this example by assigning the class already like this, and it would have had the same effect. Okay, and it's generally frowned upon. It's a bad idea to use JavaScript when HTML and CSS by itself would have done the job, okay, because you're just adding an extra complexity where it doesn't need to be. All right, the only reason I've done it like this is just to keep the examples simple to demonstrate to you what JavaScript can do. But in reality, really the times that you use JavaScript is going to be at some point after the page is loaded, when you need to change something after the page is loaded. And that's pretty much always in response to some sort of event, whether that be user input or clicking and scrolling around, or perhaps some external event. So like maybe you're loading something and some data's finished loading. That's the reason that we need JavaScript over just HTML and CSS, to dynamically respond to changes that happen after the page has been rendered. So I've got a link here to a complete reference of all the events that you can detect and respond to with JavaScript. And again, there's heaps of these. And again, I don't expect that anyone needs to memorize them all. You'll find that there's a few of them that you use a lot and some of them that you use rarely or never at all. But I only show you this to show you the kind of range of things that you can respond to. So there's maybe obvious things like change, like when any input field changes value, you can detect that as an event. Things like mouse clicks and double clicks, but you can also respond. Especially, these keep expanding as, especially with mobile devices. So you can do things like detecting the, you can basically access all of the sensors on a device, like the orientation, so you can detect when the orientation of the device changes, or you can detect motion if it's got an accelerometer, or the light level, or proximity sensors. All of this sort of stuff you can actually interface with using JavaScript. And there's more and more of these things being added as devices get more capabilities as well. Okay, but I suppose the important thing to know is that when you're referring to an event, when you're writing in JavaScript, this event name here is how you refer to it. Okay, so for example, click is going to be the string click, is fairly obvious, but there's some that are sort of abbreviated, like double click is abbreviated to DBL click, like that. Okay, but it's this column here which is the name that you need to use when referring to the event in JavaScript. So functions which we've looked at, which a function is just a repeatable section of code that can be called over and over again. They're particularly well suited to working with events because essentially we define a bunch of stuff that we want to happen in a function, and then we basically tell JavaScript to listen for a particular event and then call that function anytime that event happens. So we only have to write the code once, not once for every time the event happens. So there's sort of a two-step process when it comes to handling events in JavaScript. We write our function which defines the behavior that we want to execute when the event happens, and then we tell JavaScript to listen for a particular event. Okay, so events don't necessarily trigger things by themselves because you don't necessarily want to respond to all different kind of events. You don't want to bug the user by saying the orientation of the device has changed if that is not relevant to them. So what we have to do is tell the browser that we want to listen for a particular event. So there's two ways we can do that, and I've got two examples of that here. This first one is generally the first method that's sort of described when you're learning about events in JavaScript. Down here what I've got is, so this example here is very simple. All it does is when I click this button,
Okay, it keeps track of a variable called click count, and every time the button's clicked, this handle click function will be called, in which case the click count variable is incremented, so we have 1 added to the value, and then I'm selecting this click counter empty paragraph here and setting its inner HTML property to be whatever the current value of this click count variable is. So what that results in is essentially a counter. Okay, it increments by 1 each time the event handler is called and outputs that value to that paragraph there. So the only thing missing from this explanation is how we're telling JavaScript that we want this function to be called when I'm clicking this button. And in this case, the way this is doing it is directly on the HTML element itself. So there's the button, the click me button, and I've added this attribute called onClick, and I've set that equal to, and then inside of here you can write any JavaScript you want. You can write lines, you can write multiple statements there if you want, but generally if you write too much JavaScript there, it can become really messy. So generally what you do is you define the functionality in a function here, and then the only JavaScript you write here in this onClick attribute is the function call itself. So how did I know to use the onClick attribute? Well, essentially for any event string that I showed you in that table before, there's a HTML attribute called on and then that event string. So you can respond to any event in this fashion. And then essentially all you're doing is calling the JavaScript function which you've defined elsewhere. So that's one way of doing it. The drawback of that method is that it pollutes your HTML with some JavaScript, and as we know, it's best if you keep your HTML and CSS and your JavaScript code as separate as possible, because it makes it more maintainable and it makes it easier to figure out where all the dependencies are and where everything's going on. So we can attach the event listener a different way, and this is the same example but using a different method of attaching the event listener. So it's the same behavior, keeps track of a click counter variable, calls a handle click function, which is exactly the same, increments the click count, and then outputs that to the inner HTML of the click counter paragraph up here. The difference in this example is these 2 lines of code here. So instead of putting the onClick attribute up on the button here, what we do is we use a JavaScript function which exists on any HTML element called addEventListener. Now, because I'm not directly putting the attribute on the element here, I have to do another step first, which is to actually select the element that I want to add the event listener to, and then add the event listener to it. So what I'm doing here is I'm using document.getElementById clickMe, which is the ID of that button. And then I'm saving that in a variable I've created, which I'm just calling target, as in event target. And then to that target element, I'm calling the addEventListener function, and I'm passing it 2 variables. The first one is the event name, so in this case click, and the second one is the name of the function that I want to be the event handler, okay, which is the same handle click function I've got down here. So this is generally considered the better way of doing it because it keeps our JavaScript separate to our HTML, and that's generally always a good thing. But functionally, those 2 examples work. The output appears the same. Now there is one slight modification of this second example, which again is functionally equivalent, but I'm only showing you this because you might see this written like this, and if you're not aware of it, it can look confusing. So this is the same example again. I've got my addEventListener function, but instead of declaring the function separately down here, Okay, what's common to do is because this function and this add event listener function call are so closely tied together, is quite common to actually, rather than separate these, just include the function definition as the actual second parameter of this function call, which might seem something weird to do, but it's actually perfectly legitimate. So all we're really doing is putting this entire function definition in that second parameter of the function call. So even though it goes over a few lines, all of that is actually the parameters for this add event listener function. There's still the click as the first parameter there, and then an entire function definition as the second parameter. Now the only difference is when we do it this way, because there's no other way of calling this function, we don't give it a name. So it's what's known as an anonymous function. And this is just how you have to write it if you include it as a parameter in a function call. So really, functionally, there's no difference between doing that and writing it here, but the reason that you will see this written a lot is because these are so closely tied together, the attaching the event listener and the event handler function, if it's written like this, you can sort of cut and paste and move it around and it stays in the same place. Whereas if you have them separate, it's possible that you can have the add event listener function miles away from the event handler code. So I suppose this is just a way of keeping the code that's related to each other closer together. But if you find that inelegant or difficult to read, there's nothing wrong with pulling that function out, defining as a different function, and then simply referencing the function name as the second parameter there. Okay, and as I said, I've only showed you the click event so far, but there's lots of other events that you can listen for. But I don't have other examples for them because essentially this process is exactly the same. The only thing that will change is the name of the event. Okay, so you listen for an event on a particular element or object, and then in the function you write whatever code you want to execute in response to that event triggering. One particular one that I will mention though is this onload event. And this onload event exists actually on the window object. So just like there's a document object, which in JavaScript represents the entire document object model, there's also a window object which represents the browser window. And so it knows things like the, the viewport height and width and all this sort of stuff. And it also has events that, that can be listened to. So for example, the onload event lets you know when the page is finished loading. And the reason that's useful is demonstrated by this example here. So if I load this one up. Okay, in this example I've got just a very simple HTML document. I've got the script tag embedded in the head section of my document. And it's just a single line of JavaScript that says document.getElementById output, and which is referring to this paragraph here. And it tries to set the inner HTML to be hello. Now, if you notice in the console here, the console actually lists errors where they exist. Obviously, this hasn't worked, okay, because hello should be showing up here somewhere inside this paragraph. If I look at this error, it gives me an indication as to why it hasn't worked. So it says here, uncaught type error, cannot set property inner HTML of null. All right, and it links me to the line of code which is causing this error. So what it's saying is it cannot set this inner HTML property of null. So what that's actually saying is this here, this document.getElementById function is returning a value of null, which in programming essentially means nothing or we couldn't find it. So it's not going to be able to set an inner HTML property on an element that doesn't exist. Now, the reason that it's causing this error might not necessarily be obvious, but it has to do with what I said at the beginning of the intro to JavaScript is that the order of where you put your scripts in JavaScript matters. Okay, so what happens is that it's going to load this line by line, and it's going to load that HTML, it's going to get down to this script and load this JavaScript, and it's not going to wait for the rest of this to load before this executes. So what's happening is it's trying to select this paragraph here before it's even been loaded and created in the DOM. So of course it doesn't know anything about it, it doesn't exist. So we could make this work by simply moving this script down to some point below where that paragraph is, so that we know that that's being loaded before this script happens, and then I can run that. Okay, and you can see that it does work. But another thing we could do is, because this can get a bit dicey keeping track of where the script needs to be in relation to all of the HTML objects that it needs to reference. So a better way to handle this is, regardless of where we put the script, even if I put it back in the head here, so back where it's not working, what we can do is put this JavaScript inside of an onload event handler attached to the window objects. So we can say window.onload equals function, and then have the JavaScript inside of here. Okay, so what this is doing is it's defining, again, an anonymous function as an event handler and setting that to be the function that's called when this window.onload event triggers. Okay, and that window.onload event triggers as soon as all of the document has been downloaded, okay, and is ready to go. So we can be sure that any code that's inside of this function is not going to try and execute until all of the HTML here has already exists. So I can run this now, okay, and now it does work. Even though I've got the script written above the element that it's referencing, it still works because it comes down, loads this HTML, loads the JavaScript, it does the function definition, but it doesn't execute this until that window.onload event fires, which doesn't happen until the rest of the document is downloaded. So it's generally always advised actually to put your JavaScript inside of a event handler like this, like the Windows onload function, unless you've got a good reason not to. But it's very rare that you're going to be writing JavaScript that isn't in some way interacting with DOM elements. So generally you'll always see good JavaScript written inside of the Windows.onload function event handler. And in fact, even though I haven't specifically written it down here in my other examples, you'll notice if you look at them, if I go over here to the left, there's this section where in JS Fiddle where it says where do you want the JavaScript to run, okay, and most of them I've got set to the onload event here. So you can imagine wherever that's set, and I've got JavaScript down here, if you were to take that out and be its own standalone example, that would be written within an onload event function handler. Okay, I just want to say a few things about debugging JavaScript because you will come across errors. So the first thing is that most decent code errors will actually alert you to a lot of errors like syntax errors in the editor itself before you actually run the code. So it might do that by highlighting in red or showing a little icon or something, but it will usually handle things like you've forgotten a semicolon or you've forgotten to close your curly braces or something like this. Okay, so a lot of that can be avoided just by paying attention to that in your editor. But beyond that, the errors will be detected in the browser when you're running the code. So as I keep saying, your developer tools are going to be your best friend when it comes to figuring out if and where there are errors in your code. So there's a section of the browser's development tools, regardless of which browser it is, called the console. And as I showed you before in that previous example, and as is also demonstrated by this example, it will, if you open it up and you select the console, okay, it will actually show you where there is an error and will give you some reason for why there is an error there. So even if this description is kind of confusing for you, at the very least what this allows you to do is it will give you a position where in the code that the error is occurring. And so at the very least, it will point you to the line of code where there's an error, and you can go back and look at it and try and figure out what you did wrong. Most of the time, you've probably just mistyped something off or left something off. So that cuts down your debugging time a lot, because without that, you kind of have to go through and read it line by line and try and figure out where you've messed up, or try and figure out from what's working and what isn't, how far the code execution has gone. Okay, but in this case, it's telling me that it's this line of code here that's causing an error. And if I go back here and look at it, well, I can see the reason for it is reasonably obvious. It's because I've declared this variable number1 here, and then I'm trying to declare a variable number3 here and assigning the value of num1 plus num2. Okay, but I've never declared num2, so it doesn't exist. You can't do it. You can't do an addition on 10 plus something that doesn't exist, and so it's giving me the error that says here num2 is not defined. Okay, the other thing you can do with the console is you can actually programmatically output pretty much any data type you want to the console as well. So you can insert in your code itself, just as there's a document object and a window object, okay, JavaScript has a console object which refers to that console output window that I just showed you. And the console object has a method called log, which what you pass it as a parameter will be output into the console. So in this example, okay, I'm outputting a few different types of data into the console here. So the first one is outputting a basic string, console.log hello console, and you can see that's it there. Again, it links me to the line which is causing that to output. The second one here is I've declared a number, and I'm outputting the result of multiplying that number variable by 10. So console.log num1 times 10. See, that's outputting 100. And you can even output complex objects. So for example here, if I'm selecting this output paragraph, I'm using document.getElementById output. That's going to return me an HTML element. I can even output a complex object like that into the console by using console.log and then writing that. Okay, and you can see that there's the paragraph with the ID of output, and it's even clever enough to be able to, if I hover over it, highlight for me on the page where that element is actually existing. So this can be useful if you're trying to determine, if you're trying to determine if a certain value exists or you've done something correctly. So, for example, let's say I've just mistyped this and I can't figure out why it's not working. I can run this, okay, and now you can see it's outputting null. So null again is what you get in return when there's no value or it can't find something. So what I do is I go, well, that really should be returning this with the ID of output. I come back and have a closer look and go, okay, I've mistyped that there, fix it up, and oops, still mistyped it. Okay, and then I can run it again, and now I can be confident that that line of code is actually returning me that HTML element. You can even type code directly into the browser console if you want. So I can type JavaScript code in here. So I can type alert, for example, and I can execute JavaScript directly from the console as well. So it's sort of like you can dynamically interact with the page as well. So that can be very, very useful. And the most hardcore approach to debugging is actually to use the debugger tool. Okay, so what the debugger tool allows you to do is set breakpoints in your code. And this example doesn't work that well on JS Fiddle. So what I might do is copy it across to a new file. All right. Okay, so what I've got here is, let's run this. I need to link to my JavaScript. Okay, so what I've got here in my HTML is simply a heading and then an empty ordered list, which I'm going to use to output, using a for loop, the ingredients I've got stored in this array. So what I might want to do is, what the debugger allows you to do is set a breakpoint at one or more lines of code. All right, and the way that you do that is you, at least in Chrome, you'll go to the Sources tab. Okay, it might be named something slightly different on other browsers, but you can select any of your JavaScript files and you can put a breakpoint in at any line of code. So let's say I want to inspect what's going on at each iteration of this for loop. I can set a breakpoint here, and then when I refresh the page, okay, you'll notice that it says that it's paused in the debugger. And then I can use these buttons here, which allow me to step over the code line by line, and I can see how things are changing line by line as the code goes through. So essentially what I've got here is a couple of console.log statements, and I'm just outputting, inspecting the current value of this I variable and what the current ingredient is there, and then also outputting that current ingredient to the list. So I can see this going line by line, and I can see each time through the loop exactly what it's outputting. And I can view in my console there's the information that's getting output at each point. And I can go through again. All right, and I can see, I can watch the different variables here. And I can see this building up the list over here each time I go through the loop. Okay, until it finally finishes. All right, so again, that can be useful, especially in something like a loop construct where this is going to happen almost instantaneously. If I need to inspect and see what's going on in there, especially if something's going wrong, I can set a breakpoint using the debugger and inspect what's going on there line by line. That's probably something that might not necessarily be that useful to you unless you get into more complex sort of JavaScript stuff. But nonetheless, it's worthwhile knowing that that's there, and I've got a link here which explains more about the process and what all of those buttons and tools mean in the debugger. for the Chrome browser, and you'll be able to find similar guides on other browsers. They'll all be quite simple. Okay, I've got now, just to finish off this intro to JavaScript post, I've got a example which is just essentially pulling all of that stuff together. So it demonstrates most of the features of JavaScript that we've looked over. So I'll open it up and I'll show you what it does, and then I'll show you how I rebuilt it again from scratch. So what I've got here is a simple BMI calculator again. Okay, so I used the BMI calculation to demonstrate how a function works previously. Just to reiterate, it takes it's a calculation which takes your weight in kilograms and you divide it by the square of your height in meters. That gives you a number, and if it's between 20 and 25, that's meant to indicate a healthy weight range. So what I've done here is create a little interface that calculates that. So I've got a couple of number input fields where I can enter numbers for my height and my weight, and then I can hit the calculate BMI button, okay, which does the calculation and then outputs the value. And it also applies different CSS depending on whether this is in the healthy or unhealthy range. Okay, so if I modify these values so that the number it calculates is above 25, okay, then it will be red. And similarly, if I make it below 20, it will also be red. And if it's 20 to 25, then it will be green. Okay, and this works over and over again. I can keep entering different values there and re-clicking this and it'll recalculate it. So this is a completed example, but what I'll do is I'll delete all the JavaScript code and I'll show you how we rebuild it from scratch. So I'll start from the point of where we've got the HTML and the CSS, but no JavaScript. So for the HTML, what I've got here is a couple of labels with a couple of number inputs, okay, which you can see up here, label, input, and these inputs I've given a type number, so should only really put numbers in there, and each one I've given an ID so that it makes it easy for me to select it using JavaScript. Then below that, I've got a calculate BMI button, an ID of calculate BMI. Then I've got a couple of paragraphs. And then finally, I've got an empty paragraph with an ID of output, which is where I'll inject the number that gets calculated into. Over on the CSS, I've got some default fonts on the body element of the page. Then I've got these two classes, unhealthy and healthy, which will be applied to this output paragraph and essentially change the color to either green or red, the color and the border as well. And then the output paragraph itself, I've got some styles to make the text bigger and so forth. Okay, so at the moment it does nothing if I click on this, if I enter values, okay? There's no interactive functionality. So the first thing I need to do is, again, if we look at this logically, if I just describe this in plain terms as how I want it to work, the user enters some numbers into here, then they click this, then it calculates a number, then it outputs it. Okay, so the first thing I'm going to do is set up an event handler for this button here. So what I need to do first is select that button, which has an ID of calculate BMI, and for that I'm going to use document.get element by ID, calculate BMI like that, and then to that element I'm going to call the add event listener method, and the event that I want to listen for is the click event, and then I need to define my function, which will be my event handler. Okay, so within this function is the code that's going to execute every time that button gets clicked. What I like to do is write a bit of code, test that it's working, and then add more. If you write all of the code and then try and test it, it'll be harder to track down the errors. So all I want to do at this point is verify that this event handler has been added correctly. So I'm just going to put inside here an alert to see that it's working. Okay, so let's run that, and now I'll click the button, and if I've written this correctly, I should get an alert message. There we go, it says it's working, so I can at least be assured that this event handler is working correctly, and I can test that it keeps working multiple times as well if I like. So now that I'm confident that that's working, the next thing I want to do is extract any values that have been typed into these two fields. Okay, I'm going to need to pull those values out in order to use them to calculate the BMI. So what I'll do is I'll create a variable called height cm for centimeters, and I'm going to set that equal to, right, and in order to get this value, again, I need to first select that input field, so input with the ID of height. So I'm going to do document.get element by ID height. Okay, and then every form element or input element, like these ones here, they're going to have a property called value, which stores whatever the value currently is there. So dot value, and now that value on that height input form is stored in this variable height centimeters. Then I'm going to do the same thing for the weight, except I'm going to store this in a variable called weight underscore kg for kilograms, and I'm going to pull this out of the input with the ID of weight. So now I should have two values there, height and weight. Again, if I want, I can use the console to log and test the values that I'm getting here. Run that. Okay, so typing in something there. Okay, and I can verify with the output in the console that they match the numbers that I've typed in there. Okay, which makes sense, 180 and 123. So now that I've got these values, I need to perform the calculate BMI function. So I could do all of that within here, but what I'm going to do is define it in its own function, because it may be useful to be able to call this function from elsewhere in the code at some later point if I kept developing this. So I'll define a function down here called calculate BMI, and to calculate the BMI, it's going to need to be passed the values for height. But in this case, the formula calls for height in meters, so I'm specifying this just to make it very clear what values are being stored in which ones, and the weight in kilograms. So now I'll calculate the BMI, so I'll save it in a variable called BMI, and I'm going to set that equal to, and then I just have to write the calculation for it. So it's the weight in kilograms divided by the square of the height in meters. So I could either write height underscore m times height underscore m, or I could use the math.pow function, which is short for math.power, which takes the first variable, or the first parameter, which I'm passing it height in meters, and raising it to the power of the second parameter. Okay, so math.power, height in meters to the power of 2, same as saying height in meters squared, so that gets us our full formula, weight in kilograms divided by the height in meters squared. And then I'm assigning that value to the variable called BMI. And now if I'm going to call this function from up here, I need to return that value. Okay, so it's returning the BMI value, and then I will call it from up here. So again, I'll save this in a variable so I can use it later, and I'll say BMI, assign that the value of, call the calculate BMI function, and I'm going to pass it. Now I have to be careful here because I've got height in centimeters, but the calculate BMI function wants height in meters, so I'm going to pass it height centimeters divided by 100. That will give me the height in meters, and I'm going to pass it the weight, which is already in kilograms, so I'll just pass it as it is. Okay, so assuming this has all been written correctly, now that BMI variable should contain the BMI value for whatever numbers have been entered into here. The next thing I want to do is actually output that value into this empty output paragraph. So what I'm going to do is, again, I need to select that element. So document.get element by ID output. And I'm actually going to need to reselect that element a few times. So rather than having to write this out every time, what I'm going to do is store it in a variable called output. So then I can refer to that element by this variable name output from that point forward. So now I can set the output.inner HTML property to be equal to the BMI. Okay, and let's test that far. Okay, entered in some numbers, click calculate BMI, and it outputs a number there. Now you can see that this is giving me the number to several decimal points of precision. I really don't feel like I need this much. I only really want one. So what I'm going to do is call a function on BMI. So if you remember back when I talked about the number data type and the number object and its built-in functions, okay, it's got one called toFixed, which will round the number that you call the toFixed method on to however many decimal places you pass it as parameter. So in this case, it should round BMI for 1 decimal point. The other thing I want to do is output along with this your BMI is. Okay, so we'll test that. All right, there we go. So we've got that string that's added on at the beginning, and then we've got the BMI, which is rounded. And I just have to make sure there's a space in between there. Okay, so the next thing, the only thing really left to do is apply the correct healthy or unhealthy or healthy class to this, depending on what the value is for the BMI. So what we're going to need for that, hopefully from saying it needs one or the other, you can kind of guess what we need is a conditional statement. So what I'm going to need to do is do something like if, and then I'll sort of write it out in non-code terms first, and then we'll replace it with code. But what I'm really trying to say is, so the deal is I want to make this green if the BMI is between 20 to 25 inclusive. I want to make it red if it's outside of that range, so if it's over 25 or under 20. So we'll deal with the healthy version first. So we're going to say if the BMI is between 20 and 25 inclusive, then healthy. Else if BMI is greater than 25 or less than 20, then unhealthy. Okay, so basically what we need to do is this is the logic, but we need to write this in terms that JavaScript is going to understand. So to write this as a conditional statement, if BMI is between 20 and 25 inclusive, the way that we would say this is if BMI is is greater than or equal to 20, and BMI is less than or equal to 25. So essentially we have to split up as two conditions. Now this double ampersand here is what's known as a logical operator. Essentially that's a logical AND operator. So what that means is this entire condition will be classed as true only if this condition and this condition are both true. Okay, so that's how we essentially say if the BMI is between 20 and 25. If it's greater than or equal to 20 and it's less than or equal to 25. Okay, now on the flip side of that, how we say if the BMI is greater than 25 or less than 20, again we have to split it up essentially into two conditions. So I say else if the BMI is greater than 25 or BMI is less than 20. So in this case, I've used this is a logical OR operator, okay, and that single character is called the pipe character. If you've never seen that before, you type that by holding down the Shift key and hitting backslash. So essentially, this is a logical OR operator, just as this is a logical AND operator. With the logical OR operator, it will evaluate this whole condition as true if either of those conditions are true. Okay, so by saying if the BMI is greater than 25 or if the BMI is less than 20, then this will happen if either of those conditions are true. So that covers both bases for us. This will be executed if the BMI is between 20 and 25. This will be executed if it's greater than 25 or less than 20. So all I need to do now is apply the correct class name to the output paragraph. Okay, and this is why I said before that I'm storing this element selection in the output variable, so I don't have to write this again. Instead, down here I can just refer to the output variable again and set the class name to be equal to healthy. And in this case, I can set the output class name equals unhealthy. Okay, now let's run that. Again, I'm going to put in some values here. Hit calculate BMI, all right, and it outputs the BMI, but it's also outputting the correct class. All right, and I can verify this by looking at the element section of my dev tools. Okay, if I run this again, okay, there's my empty paragraph output, and I can see when I enter information in here, as soon as I hit calculate BMI, you should see the healthy class added to that paragraph. Okay, and if I change the value so that BMI is greater than 25, changes it to unhealthy. All right, and I should also test less than 20 as well. Okay, still keeps the class unhealthy. Now you will notice in the final example I actually do have one more condition here, because it may seem like we've covered all bases here, but what it hasn't covered is actually the scenario where someone clicks calculate BMI without entering anything in here. And what you'll see is that it outputs your BMI as NAN. NAN is a special data type value which stands for not a number. It's essentially what happens when you try and do a mathematical operation on something that isn't a number. And so the something that isn't a number here is because there's nothing in here. When I'm trying to pull the values out of these inputs, they're both going to be assigned a value of null, nothing, okay? And so it can't perform a calculation on that, and the result you get is not a number. So what I can do is I can add an else here. and say, well, that covers if BMI is between 20 and 25. That covers if it's above or below. All right, but this covers everything else, including that it's not a number at all. So basically what I'm saying here, if it's neither of those, then the value is something wrong, and so you've probably not entered a height and weight correctly. So what I would do here is I'd just say output.inner HTML equals, and I'd output some error message. So I'd say something like, could not calculate BMI, please enter a value for height and weight. Okay, something like that. All right, now when I don't enter anything, it rather than, okay, it gives some sort of elegant error message feedback rather than something that looks confusing. Okay, so error handling is actually a big part of whenever it comes to adding interactive stuff, is because you've always got to assume the user is going to do something wrong. Fortunately, that's not something that you really have to deal with in this subject, but it's something to be aware of. Okay, so that's how we build that example, and essentially the bits and pieces and techniques that we've used in there will cover pretty much anything you want to do with JavaScript. So if you understand that stuff enough to know what's going on, okay, then then you're at a good point, I think, there. If you can, in some way, even if you don't remember exactly how to write everything, understand what these things are doing, then that's kind of where I want you to be at. Okay, and finally, before we move on to the jQuery stuff, I've just got some more resources here. Okay, again, there's some reference resources like the Mozilla's JavaScript reference. There's the W3 Schools has a JavaScript section, and Stack Overflow is a good site where you can ask questions about usually programming stuff and people will give answers. So you can ask questions here, or you can search through previous questions that other people have asked and the responses to them. Okay, and then there's the interactive learning and tutorials links like Code Academy, which I think I mentioned in the lecture, is kind of interactive JavaScript learning, and then also a link to JavaScript tutorials on Lynda for video tutorials. So that's JavaScript.